Okay, guys, greetings once again, and welcome to another edition by iCampSA. In this edition, we're still looking at linear regression, but our focus is on the 2021 exam, that is the June and the November exam. We're still looking at statistics, that is grade 12 mathematics. So let's have a look at this question from the 2021 November exam. So the statement reads, a farm stall sells milk in 5-liter containers to the local community. The price varies according to the availability of milk at the farm stall. The price of milk in rands per 5-liter container and the number of 5-liter containers of milk sold are recorded in the table below. Okay. So we are told 2.1 on the grid provided in the answer book, draw the scatter plot to represent the data. So this is 2.1. So if you look carefully, this is the grid that we are given and we are required to plot the scatter point. So I'm going to start with this one, 26 and 48. So if you look carefully, this is 21, 22, 23, 24, 25. So 26 is here. So 26 is this line, start line. And 48, if you look carefully, this would be 46, 47, 48 is there. Okay. So what this means is I should have a point there. Okay. Then I delete these two lines. Okay. That is where 26 and 48 they add. Then I go to the next one, which is 32 and 30. So if you look carefully, 32 should be here. And then 30 should be there. So if you look at where these are supposed to cross, it's at that point. Okay, so I can just delete this and delete that. Right, and then you'll see that we now need 36. So we need 36 and 26. So we have 31, 32, 33, 34. So 36 is just after 35. So we have 36 and 26. So 26 is just after 25. Okay, so that means I just need a point there. Okay, then I can go ahead and delete this here. Then up to the next one. So we need 28. So 28 would be 26, 27, 28. It's this line. We have 28 and 44. So 41, 42, 43. So 44 is just below 45. Okay. So we can now put in our mark. We delete that. Delete. Right. And then we can now go to the next one where we're looking at 40 and 23. So that should be very simple. 40 is the last one. And then we have 23, which is after 21, we count 3 times after 20. 21, 22, so 23, somewhere there. So that means I just need to make a point here and then delete this line, the top one. Okay, done with that. We go into 33 and 32. So with 33, we just count 3 lines to the left of 30, to the right, sorry. And then 32, it's just 2 lines above 30. Okay. Okay, so that is 32 actually. So we're looking at 33. So 33 is here. Okay. So what we have is a point there. Delete and delete. right? And then we go to 29 and 39. So 29 is just before 30. Okay. And the 29 goes with 39, which is just below 40. Right. So you will see that we're going to have a point there. Then just need to delete these. Okay. So that is what we have. Then we can go to 34 and 29. So 34 is just before 35. And we're looking for 34 and 29, which is just below 30. So if you look at the mark we're supposed to make, it's here. Okay. So let's delete. And then we're now going for 27 and 42. So let's see. So 27 is, we have 26, 27, 27 is here. 27 and 42. So that is 1, 2, 42 is there. So this means we're looking at a point that is sitting there. So delete. So it's very important that you guys look at your sketch carefully. So we have 30. So 30 is on this vertical line. And 30 is going with 33. So that's 1, 2, 3 here. And we just need to put in a point here. Right. So let's delete and delete. So that becomes our scatter plot. Okay. And you would got all the marks which would be allocated to that question, 2.1. Right, we're done with 2.1. Let's go to 2.2. So for 2.2, so for 2.1, what you should do is see next page. Okay. Then now what we want to do is to deal with 2.2. So for 2.2, we are required to determine the equation of the least squares regression line of this data. That should be very simple. So essentially they're asking us what is y equals a plus bx. In other words, what is a equal to and what is b equal to? That is what we need to go and figure out. And in order for us to do that, we need our calculator, guys. Right, so clear shift 1. We need to go to our data, a plus bx, and we need to insert our data here. So if you look at the x, we have 26. So you say, okay, 32, that's okay. Then 36, that's okay, 28. Then we have 40, 33, then 29, then 34, then 27, and 30. Right, and then we go to the next part where we put in our y's, which is what we see just below. So that is 48, 30, 26, 44, 23, 32, 39, 29, 42, and the last one, which is 33. Right. So now that we have this done, we can go and look at our values for A and B. So shift, we go to regression, then that is our value for A. So as you can see, our value for A, we are finding 90.48. Okay, and then let's go for B. So the value for B, that is -1 point. If you observe carefully, 77. Okay, so this means we can now finalize our answer, which is just going to be, therefore, y will be for A, we have 90.48, then minus 1.77 times x. So this is what they were looking for as our answer. So this is the equation of the least squares regression line. Okay. Then the next question, 2.3, we are asked, if the farmer sells 5 liters of milk for 38 rands, then we need to predict the price of 5-liter containers that he would sell. So remember, here we're looking at the price that he's selling at, and at the bottom, we are trying to figure out the number of 5-liter containers they are gonna sell. So what this means is we have the x. So we have x equals 38, and we are trying to figure out what is y. Okay, because y is really determined by demand. So we'll have y equals, we'll have 90.48 minus 1.77 into 38. So this y will be equal to, let me use my calculator, 90.48 minus 1.77 times 38. What I end up getting is 23.22. Okay, so I can just approximate to say what we are looking at is the number of 5-liter containers they are going to sell. So we can say that our answer, we can say that the farmer will sell, if we round that off, we can say 23 5-liter containers. Okay, if they are selling them at 32 rands. So I hope that this does make sense to you guys. Then let's have a look at the next question, which is 2.4. They say refer to the correlation between the x and the y, essentially, and then we should comment on the accuracy of our answer. So what we need to first determine is what is the R value. Okay, that's very important. So let's go to 2.4. So for 2.4, the first question we should ask ourselves is, what is the R value? So I'm going to go to my calculator quickly and determine the R value. Shift 1 and correlation coefficient. Sorry, that is not accurate. Shift 1, correlation coefficient. I'm getting negative 0.94. Okay, so I'm getting negative 0.94. So this is 0.9, so it means we have a strong correlation. So what we can say is, we can say that our calculation is accurate because we have a strong, but since there's a negative, it's a negative correlation. So here we can say our, if you look carefully, our calculation we can say is accurate. So we can say our calculation is accurate. Okay, why? This is because there is what is very important is this term here, strong negative correlation. And this is between your x and y. Okay, so that would be our answer, to say there's a strong correlation between the variables of interest, which is, in this case, it is our x and our y. And the teacher would be very proud and happy of us for providing these answers. So please make sure that you guys are able to interpret and you are able to comment on the accuracy of your answers. So if you found an R value that was very close to 0, then our estimation would not be accurate. Okay, this is very close to -1. So it is a strong correlation because it is close to -1. Okay, done with this question, guys. Let's go and have a look at the next one. And on the next question, we're looking at the 2021 June exam. And we are told the wind speed in kilometers per hour and temperature in degrees for a certain town were recorded at this time here for a period of 10 days. So the information is shown in the table below. So the first question, they want us to determine the equation of the least squares regression. So let's go ahead and cook. So we're looking at 1.2.1. So what they are looking for is what is A plus BX. So what we need to ask ourselves is what is A and what is B. So our calculator then comes in very handy in such a situation. So let's go to where we have our data and then we just erase. Then we put in our data. So we have 2, if you look carefully, 6, 15, 20, 25, 17, 11, 24, 13, and 22. Then we go up, we put the corresponding Y values. So that is 28, 26, 22, 22, then 16, then 20, then 24, 19, 26, and 19, right? Then after we're done with this, we can now go and check our data, shift 1. We're now looking for our variables. So regression, we have our A value. So the value of A, if you look carefully, that becomes 29.35. Okay. Then let's go for the value of B, shift 1. In your calculator, you would see stats. Then you would choose reg for regression. Then we go for our B. And the value of B, just going to make it to be -3 decimal, -0.462, if you observe carefully. Yeah. So let me take A as 3 decimal places, if this is the case. So we're going to have 29.35. This will be 4. Okay. So that is what we have, guys. So therefore, our answer will be Y equals our A, which is 29.354, then minus 0.462 multiplied by X. This here is our answer. That's what they are looking for. Okay. So let's have a look at the next question, 1.2.2, where we are required to predict the temperature at 1600 hours on a certain day if the wind speed is 9 kilometers per hour. So essentially we are given what X is, which is 9, and we are required to figure out what is Y going to be, where we are predicting the temperature, Y. And this is very simple. We just use the equation. So our Y will be 29.354 minus 0.462 into 9. So let me use my calculator. 29.354 minus 0.462 into 9. Then what we end up getting is 25.8 If you round it up, you get 2. So what this means is our temperature when the wind speed is 9 kilometers per hour, our temperature will be 25.2. Okay, so that is our answer. Our answer is that our temperature will be that the 25.2 degrees Celsius when our wind speed is our 9 kilometers per hour. Okay, that's what is going on. Okay, and then now let's have a look at 1.2.3. So we are required to interpret the value of B in this context. So remember, we have y equals A plus BX. Okay, so when you look at B here, B is really the gradient. But if you think carefully, it is the change in y, which is the change in temperature with respect to the wind speed. Okay, so if you think carefully, our B is given by our change in temperature over our change in wind speed. So what we can say, it is the average change in temperature per kilometer. Okay, let's think about it carefully. So it's the average change in temperature per kilometer so wind speed is kilometer per hour. So per kilometer per hour. So that is what we can say. So we can say our B is the average, it is the average change, or if you observe carefully, the higher the temperature, or if you look carefully, the lower the temperature, the higher the wind speed. So we could maybe phrase this way. So we can just phrase it as the change in temperature with respect to speed. But if we observe carefully, you'll see that the B for our case, because they are saying we need to interpret rather than describe, the B is negative 0.462. So if you look carefully, it means our gradient is decreasing. Okay, so what this means is that our temperature is decreasing with respect to speed. So let me think carefully. So on the horizontal axis, what we have is wind speed, and then on the vertical axis, what we have is temperature. So because we have a negative there, that means our graph looks like this. So it means as speed increases, our temperature decreases. So yeah, that should be our analysis here. So let's go ahead and put that down there. So analysis is that as the wind speed increases, the temperature decreases. So as the wind speed increases, the temperature decreases. And this should make sense because the wind has a cooling effect. So if the wind speeds are very high, then temperatures in whatever body you're looking at will decrease. Okay, So I hope that you guys understand the answer to this. But what I want to do also is to look at my correlation and we quickly describe it. So how is our correlation for this data here, R? So what I'm going to do, I'm going to quickly go to our calculator and retrieve our R. Very simple exercise. So there we go. We have 0.93. So it's negative 0.93. So R is negative 0.93. So it's above 0.9. So we can say we have a strong correlation. Okay. But for this case, it's going to be a strong negative correlation. Hope you guys are able to make sense of that. So let's put temp here. Okay. So you can see that we can say that X and Y, which they are described what they are, they have a strong, very important, but this is negative correlation. Okay, that is just the description of what is happening between the two variables. They have a strong correlation, but it is negative. So I hope that you guys understand what is happening and all the questions that we did answer here. So this brings us to the end of the 2021 paper looking at linear regression, and this is brought to you by iCampSA. Cheers guys, enjoy.